This is Algebra Lesson 1-1, Variables and Expressions. As I go through these vocabulary words, be sure to leave yourself time to be able to write everything down, which means you may need to pause this video as we are going through these. If I write examples down, it would be highly advised that you do the same thing. A quantity. A quantity is anything that can be measured or counted. It's like a number, like 6. You can have 6 bikes, you can have 12 cars, you could be $4 in debt. So a quantity is anything that you can measure or you can count. A variable is a letter that stands for a number. Some examples of variables are T, Z, X. Be careful when you write lots of your variables to make sure that they are easily seen to be variables versus numbers. I don't use an L because it looks like a 1. We don't use an O because it looks like a 0. I make sure that I put my X's with a little tail like this so that it looks like an X versus a multiplication symbol. I also make sure I put a tail on my T so that it looks like a T and not a plus sign. But any variable pretty much can be a letter. The only letters we do not use is we do not use a lowercase I, because a lowercase I stands for the imaginary number, and you'll get into that when you get into Algebra 2. But anything else is pretty much fair game, as long as it looks like a letter versus a number. An algebraic expression is a mathematical phrase that includes numbers, variables, and operation symbols. An example of an algebraic phrase could be something as simple as 2, or it could be something like x plus 6, or it could be very complex, such as something like x squared plus 3xy minus 9y to the third. All of those are considered to be algebraic expressions. They are expressions because they do not have an equal sign, which makes them different from an equation, which would have an equal sign. A numerical expression is a mathematical phrase involving numbers and operation symbols, but no variables, like 2 plus 6. That's a numerical expression. Or 3 times 9. And do notice there's many different ways to write 3 times 9. I could write it with parentheses. I could write it with a little asterisk. I can write it with the x as a multiplication symbol. Or I can do some other things, which we'll get into later. Variables are very helpful if you want to write expressions where part of the expression will stay the same and part of the expression may change. Because a variable can change, it is something that will vary. That's why it's called a variable. You want to be able to write variable expressions because then if something changes, the only thing that you need to change is the variable itself versus the entire equation. For example, how many miles you can drive on 10 gallons of gas depends upon many factors. What type of car you're driving, how you drive, what type of terrain you're going over, and etc. So if you know you have 10 gallons of gas and you know the type of vehicle you drive, you can make an expression using variables and constants. If you know that that m is equal to the number of miles you can go on 10 gallons of gas, m divided by 10 is going to be the number of miles that you can drive. So your expression or your equation would be m divided by 10. Now, in order to be able to work with variable expressions, you have to know the basic words that mean mathematical operators. And the basic mathematical operators are addition, subtraction, multiplication, and division. Now, different English words will imply whether you're supposed to add, subtract, multiply, or divide, and I've written them down here. You may want to pause the video as you write them down. Some of the most obvious ones and the most used expressions for addition mean sum, total, more or more than, increased by, in addition, or they sometimes say in addition to, greater or greater than, and obviously add. If I say the sum of 6 and 5, that pretty much means I want you to add 6 and 5 together. Subtraction is basically taking all of your addition ones and reversing them. The mathematical phrase for addition is sum. The mathematical phrase for subtraction is difference. So the opposite of a sum is a difference. So we have less and less than, fewer, decreased by, the famous take away, when you did that when you were younger. If I have 6 apples and I take away 4 apples, how many apples do I have? Minus and subtract. There are more words for addition and subtraction than there are for multiplication and division. However, there are some things that imply multiplication and division that you wouldn't think always do. So you have to read the entire phrase in context. For multiplication, we have a product, or sometimes times, and sometimes we have the word of. Of is sometimes used as meaning multiplication. It's not used all of the time. It's also a preposition in English, so it can be a little confusing. In division, we have quotient, divided by, break into equal groups, or put into equal groups. So everything in this first column means we're going to add. Everything in the second column means we're going to subtract. In the third column, we're going to multiply. And in the fourth column, we're going to divide. Now, we need to learn to translate word phrases into variable expressions. And it's really, really important that you pay attention to the order in which things are given. If I say 7 more than n, that means n comes first. That means n over here came first in my equation. If I say that my brother is 3 years more than I am, that means he was born first. The phrase more than or less than implies that whatever comes after that, the word than, actually comes first in the equation. Now, obviously, with addition, the order really doesn't matter because 5 plus 7 is the same as 7 plus 5. However, with subtraction, the order is absolutely critical. So the more that you can pay attention to the order in addition, you will pay attention to the order in subtraction. So if I say 7 more than n, that means that this n is going to come first. So I'm going to put n plus 7. That means 7 more than n. The sum of n and 8, here, because it's just the word sum, it doesn't really matter. We can put n plus 8, or we can put 8 plus n. Now in question 1 here, 7 plus n is not wrong. However, if you pay attention to the more than and less than, and you do it while you're doing addition, you'll be less likely to make a mistake with subtraction. Because when we get to number 3 here, 6 less than b, that means b came first. 6 less than b, that means this b came first. Okay, so that means I have the b, and then I have 6 less than that, because there's a major difference between b minus 6 and 6 minus b. Think of it as 2 minus 3 and 3 minus 2. 2 minus 3 is negative 1, and 3 minus 2 is positive 1, so there's a huge difference there. So the order is absolutely critical when we work with problems of this nature. Number 4 says the quotient of n and 7. Whenever you're dealing with a quotient, you do them in the order in which they are written. So the quotient of n and 7 means we're actually going to take n and divide it by 7. Now we're looking at trying to write things algebraically, because we are in an algebra class. Therefore, if I'm trying to write something algebraically, I want to make sure that I write it the right way. Now, mathematically, we would use the little division symbol that there are many of in order to do this. In algebra, we would use the fraction bar because the fraction bar implies division. So n divided by 7 algebraically would be written n over 7. Mathematically, it would be n divided by 7 or n divided by 7. Both of these are mathematical. They're not wrong, but they're not algebraic. So if your directions say you have to write an algebraic expression, they would be incorrect. They are correct mathematically, but not correct algebraically. Now, if I have the number the phrase 4 times the quantity 8 plus a number d, here's where we have to pay attention to the fact that there's a couple of things going on here. Excuse me. We have 4 times the quantity. This word quantity implies parentheses. It implies that something, 4 is multiplied by a group of something. So this quantity 8 plus a number d implies that the 8 plus a number d comes in parentheses. So 8 plus a number d here. And then we're going to multiply that by 4, and we show that we're going to take that entire quantity and multiply it by 4 because it's in parentheses. And the 4 can go in front, or the 4 can go behind. Either one is correct. They both mean the same thing. It just means that we're going to take 8 plus d and add those together first before we multiply them by 4, or we're going to distribute the 4 through the 8 plus d. Now, sometimes we have more than one variable when we're dealing with things, or more than one operation. In all of these examples, except for the last one, we only had one operation going on. We were either adding, we were subtracting, we were multiplying, we were dividing, until we got to the last problem, which had us multiplying by an integer quantity. So when we have things that we're translating into more than one operation, we have to pay attention to the order of how things are written. So if I have 10 more than twice a number x, that means this 10, this twice a number x, has to come first. This comes first in my expression. So twice a number x basically means 2 times x, which algebraically we would just write with a 2 next to the x. We don't need to have any type of symbols implying multiplication, because if you have a number next to a variable, it always implies multiplication. It doesn't have to be expressly written that it's 2 parentheses x or 2 times x. And we do 10 more than that, that means this comes after this stuff here, so we're going to add 10. So we're doing 2 operations within this one particular problem. Number 2 here says the sum of twice a number q and 31. Okay, the sum of. Okay, and here's where this word of does not mean multiplication. This is a preposition. The sum of twice a number q and 31 here does not imply multiplication. So twice a number q and 31. The sum means this is coming in between these. So I'm going to take twice a number, that becomes 2 times n, or 2 times x, or 2 times p, or 2 times whatever variable you would like. But in this case, it's q. I should have read my problem better. So it's twice a number q, because it said that, and 31, the sum of those. That's where the sum comes in between these, and it gets replaced with the word and. So twice a number q becomes 2q, and 31, and then we have this sum, so the sum becomes right there. The more you do these, the better you get at writing them. The more familiar with them you are, the better you will get at solving word problems when it comes to algebra. Number 3 here says 7 less than the quotient of 8 and a number x. So we've got 7 less than, which means this is going to come after everything else. Quotient means divide. 8 and a number x. So the quotient of 8 and a number x means I'm going to take 8 and divide it by x, because when we talk about quotients, you keep them in the order in which they are written. So the quotient of 8 and a number x means 8 divided by x, which we write as a fraction. And then 7 less than that, we have to subtract 7 from that. So we get 8 over x minus 7. Number 4, the product of 9 and the sum of x and 2. The product of 9 and the sum. This word and here is a conjunction in English. It means this. That means this sum of x and 2 literally has to come first, and then we're going to multiply that by 9. So the sum of x and 2, this we write as x plus 2, but we have to put it in parentheses because we know we need to multiply 9 by all of that. And the only way we can multiply 9 by all of the sum of x and 2 is we have to put x and 2 in parentheses, and the 9 has to be on the outside, either in front or it can come behind. It doesn't matter as long as it's in the problem somewhere. Now we're going to take some algebraic expressions and we're going to write them in word form. Okay? We have them algebraically. We're going to translate them into words. So we have x plus 8.1, and literally you could write that as an algebraic expression. X plus 8 plus 1. 8.1 is a perfectly fine algebraic expression. You can say x plus 8.1, or you could say the sum of x and 8.1, or you can say x increased by 8.1, there are several ways to do this, as you can clearly see, which means there can be more than one answer that is correct. All right? So don't think that if you're talking to somebody and somebody says it's x plus 8.1, and you go, no, I think it's the sum of x and 8.1, don't think that they are right and you're wrong, just simply because you got the different answers. Different answers are fine in mathematics as long as they are mathematical answers. Let's look at number 2. Number 2, we have an x multiplied by 5, and then we subtract 1 from that. We could literally write x multiplied by 5 and then minus 1. All right, but that one's probably a little harder to follow. I would probably put something to the effect of, and I'm going to change colors here so that we don't get the first problem and the second problem confused. I would write something more like 1 less than the product of 5 and x. But that's me. 1 less than the product of 5 and x. That is one perfectly fine phrase for 5x minus 1. Okay, or you can have 5 times x decreased by 1. There are many different ways to write this out. As long as it's mathematically sound, it is perfectly fine. Different people will interpret it differently, but as long as you have the same interpretation as to what comes first and second, you'll be fine. Number 3 here says that we have n over 3 as a fraction. And remember that fraction bar stands for division. So we can say n divided by 3. That would be a perfectly fine phrase here. Or we could say the quotient of n and 3. Either one of those are perfectly fine. And those are probably the most common ones that people would use if they saw that particular expression. All right, now, we often talk in mathematics about real-world situations. Real-world situations just means problems you would see out in the workforce, out in your job, out in your day-to-day, everyday activities. It's not saying like school is a fake world and everything else is a real world. It's just saying that if you go outside of the classroom, these are the types of situations in which you might use these mathematical properties or procedures. So here it says, a table shows the cost of renting a scooter depends upon how long the scooter is rented. What is the rule for the total cost? Give the rule in words and as an algebraic expression. So I'm looking at this lovely little rule here, and I'm seeing, well, if I rent a scooter for 1 hour, it's going to cost me $17.50. If I rent a scooter for 2 hours, it's $25. Well, it doesn't double. $17.50 times 2 would not be 25. So I know that it's just not $17.50 an hour. I know I'm not having to rent a scooter for just $17.50 an hour. So I have to figure out that there's got to be a pattern between these numbers. So what I do is I take a look at my costs and I go, oh, from $17.50 to $25. Well, that goes up by $7.50. From $25 to $32.50, that also goes up by $7.50. And then from $32.50 to $40 also goes up by $7.50. And $40 to $47.50 also goes up by $7.50. So each of my cost increases is $7.50, which means to me that my brain thinks that, ooh, I probably have to spend $7.50 per hour, and then I have to pay either a deposit or maybe there's a rental for my helmet or something of that nature. So if I was to take all my hours and multiply them by 750, if I multiplied 1 times 750, I would have 750. If I multiply 2 by 750, I would have 15. If I multiply 3 by 750, excuse me, 750 times 2 is 14, not 15. Just proves we can all make mistakes. So this would be 14, and then 3 times 750 would be 2250. 4 would be $28. And 5 times 750 would be 3750. No, 3250. I can multiply. Okay. So if I'm looking at all these problems here, if I take all my problems and I'm looking at this would be 3750, like I said here. If I was to look here and I go, okay, to get from 750 to 1750, I'm adding 10. Okay. No, 750, but I was right the first time. 750 times 2 is 15. Boy, I'm having a really hard time here, aren't I? I should always go with my gut. 15 to 25 is adding 10. 2250 to 3250 adds 10. 28 to 40, now that doesn't add 10. That should be $38. So I'm thinking, maybe there's a problem here. Because if you look at 750 times 4, it is, 750 times 4 is $30, not $28. Wow, I made a mistake there too. This is how you can determine whether or not you've done something right. If it's like, oh, I have a pattern. No, I don't have a pattern. You can go back and say, what did I do to mess up? I really messed up when I multiplied 750 times 4. Okay? Because I went with my 14, and 14 times 2 is 28, which messed my whole brain up. And then we add $10 here, and we add $10 here. So I can clearly see here that I'm going to multiply the number of hours by 750. And then I'm going to add $10 to it. So every answer I have, if I wanted to rent the scooter for 15 hours, I'm going to take 15 and multiply that by 750, and then I'm going to add 10 to that. So if I wanted to rent that scooter for 15 hours, it would cost me $122.50. So this told me to give the rule in words, which I've done right here, and as an algebraic expression. So as my algebraic expression, I'm going to look at cost and hours. So my cost will equal $7.50 times the number of hours plus 10. And of course, I should define my variables here. Right? So I'm going to say that C equals cost and H equals the number of hours. Okay? So this is what we consider to be what we call a real world expression. Alrighty. Last thing, I want you to think for a moment and write at the bottom of your notes or at the end of your notes the answer to this question. Every lesson will ask you a question to answer at the end, and it's kind of like a culminating question of, did you understand what this video was about? I'm not looking for a 5-paragraph answer here, but I'm looking for more than just a couple of words. Okay? So make sure that you explain everything fully when the question is asked. So the question I'm asking you today is, how is an algebraic expression like a numerical expression? And how are they different? So you can just simply say they're both this and they are different this way. So please explain that in your notes, and I will see you next class.